back. Today we're going to talk about database development lecture 27, the data warehousing and introduction. So this is the final chapter, and we'll return to the relational database again. But now we're using different use cases, which is the data analyze, and using different technology, which is called data warehousing. So we have learned many analyze methods in SQL before. So first of all, is group by method, and group by keywords, where we can split this result by group by different keywords. And for example, we can select the lecture.name, module.name. From module, then lecture, we code equals to module. And maybe we can count how many each module have. We can have select lectures.name count and count extroid. From modules lectures, we code equals to module group by lecture.name. We can see how many lectures did how many modules did one lecture teach. So intuitively, we can have select all modules lectures with code equals to module, and we can group by maybe like GF has these two modules and MG has these two modules, has this one module. And having is just like a condition that in SQL where condition comes and it's interpreted before the group by. If you want to do a where after the group by, use the having. So and we also have some aggregation function, just like count and sum and so forth. But now we're going to talk more depth about data analyze, and so many big companies want to analyze its product sales. Maybe has the product database schema like that. Maybe like sales, product number, date, store name, price, and we have a store. We have the name, city, country, and so on. And for example, we have some queries like select country average price from store sales, where the store name equals to the store dot name, and the date is greater than 2019 June 1st, and we can group by country. Maybe another example is about the healthcare analysis. A hospital wants to analyze the risk, the best model of treatment. There's some possible schemas, which are the app store of the care. We have the date, the patient ID, the diagnosed ID, the treatment ID. The patient, we have the patient ID, name, age, and gender. And diagnosis, we have the diagnosed ID, and the treatment has treatment ID. So we can analyze for the best model of treatment given a certain diagnosis and the average length of study. So what is the problem? The queries in this application tend to be complex, and we are going to examine a large number of data. Therefore, this is a problem. And how do we do that? By introducing a data warehousing. What is data warehousing here? It's just a group. Data warehousing is just a group of things. It's just a database. It's a database to select all the things that we are going to need for analyze, and extract them from the original database, which is on the left-hand side, and put them in the data warehouse. And then the data analyst can only use the data from the data warehouse to do the things. And there are two kinds of the data analyze, which is OLAP and OLTP. The OLAP is called online analytical processing, and refers to the process of analyzing the complex data stored in the data warehouse. And the OLAP query, we have a query used in the OLAP, typical just like select country, average price, from sales and stores, where sales.store name equals to stores.name, and the date is greater than equal to the 2019 June 1st. We can group them by country, and TP is just involves the feature of the transaction, and the queries can update execute fast, and often affect a small proportion of database. So apart from that, there are some data models for the data warehouse. For example, we have the fact table and data cubes. For OLAP applications, there's typically a unique fact table, and it represents the events, objects, of interest of the analyst. The example fact table is called sales, product number, date, store, and price, and maybe sort out as representing a data cube. For example, just like each point is the sales of product, we have 3 dimensions in describing a product, which is called date, sales, and products. And each there is one dependent factor on these 3 factors, which is price. So these three dimensions can be used to describe this feature. And there are some the schema used here in the data warehousing is called fact table and dimension table. As is known to us all, that the schema is used to demonstrate the infrastructure of this table. So here the infrastructure is called star schema, and we have the product number comes from the products, the date comes from dates, the stores come from the stores, and price is the center of the star. And the star schema, we can do it more precisely. For example, we have one fact table with the relation A1 to AN, B1 to Bn is just the dependent variable, and the A1 to AN is called dimensions. And the dimension table DI with attribute AI and so forth is the key for the AI is the key for DI, and more general it's like a snowflake schema, but not demonstrated here. So there are some key characteristics of the star schema is that it is not normalized schema, since one data can be replicated in many tables, and the rest of the data can be joined with the fast table very quickly. So there are some gains of the star schema where the query don't require many joins, and since the join is the main cause of the relational the SQL statement, and the performance gain is especially when processing the queries that would require many joins, for example, and we can have a faster aggregation of data. And it's also easy each aggregation and grouping of the data in many different ways. And for example, we have the sales, product number, date, store name, price, products, product number, type, model, stores, name, city, country, phone. We suppose the product X doesn't sell too well and want to which model does not sell too well. Select model, sum price, from sales, natural join products, where type equals to X and group by models. And we can refine by the month. We can add some month features to the query. If we add the month, we are going to change from this one to this one. And the techniques used here is the slicing. We use the group by. The dicing we use group by, and slicing we use the where. Just like in this one, we use the group by. So we are dicing. The dice is just a small one, so it's many small one. And the slicing is the where we are cutting one part of it as a whole. And the data warehouse and database is a system that supports the analysis of data. So analyzing data in a data warehouse called OLAP. It contrasts to OLTP, which is called traditional transaction processing. And the queries in OLAP set is called OLAP queries. Data in the data warehouse table structure in a data cube using the star schema, and we have the performance gain and easy flexible aggregation. Next lecture, we're going to talk about the data mining. Thank you very much. Welcome, comment, subscription.